Welcome students. Light is a most contradictory entity. We know. Sometimes it provides particle nature, sometimes it provides wave nature also. In particle nature, we know Newton's first told that Newton's corpuscular theory, so that light are the particles and each particles are named as corpuscles or corpuscular theory. Okay, this is called corpuscular theory. According to this theory, the speed of light is 3 into 10 meter per second, and also each corpuscles move with constant speed, which is equals to 3 into 10 meter per second, and corpuscles are massless particle, and basically rest mass of the corpuscles are 0, and corpuscles travels in straight line, and some other property also. Okay, but after 100 years of Newton's corpuscular theory, we see some properties of light like interference, diffraction, polarization. This property cannot be explained by Newton's corpuscular theory. Then Huygens, scientist Huygens, introduced a new theory, that wave theory of light. So here is the table by some phenomena of light which can be explained by the corpuscular theory and wave theory. Reflection, diffraction, dispersion, reflection, refraction, and rectilinear property. This property can be described by corpuscular theory and also by the wave theory of light, which is introduced by Huygens, and some other property like dispersion, interference, diffraction, polarization. This property of light cannot be explained by corpuscular theory. Okay. So we need another theory, which is wave theory. Okay, and also then other double refraction, Doppler effect. This is also the phenomena of wave. And again, after about 100 years later, when the phenomena comes photoelectric effect, then also the wave theory failed to explain the phenomenon of this phenomena of light. Then Einstein gives a new theory of light. Again, it is also a particle nature of light called photons. This is the short history of theory of lights. So now we will discuss the wave theory of light, Huygens wave theory. But that time Huygens first told that light is a wave, but that time electromagnetic wave is not discovered. So they known that to travel wave we need a medium. Okay, one medium is needed. So the scientist introduced the theory of ether medium. They told the universe is completely filled with a medium which is called ether, through which wave can travel. Okay, and according to Huygens wave theory, the light from a source is traveling all direction of like wave. This is the wave theory. And as light is a wave, it has also the phase point and also amplitude, okay, and intensity also. So he introduced a new term called wave front. Wave front is the basically the front of a wave. If I take a wave moving along same direction, the locus of same phase point, okay, is called wave front. Okay, let me draw some waves. Let us take one wave is moving this. I have drawn here 3 waves emitting from a light source, say. Okay, this is a light source, halogen light. Okay. So these waves are moving along right direction, and if I take same phase point, means if I take 3 point over, let's say this and this, these 3 points have same phase, and if I draw a plane on this point, this plane is called wave front of wave. Okay, that means the locus of all particle vibrating in same phase is known as wave front. Okay, type of wave front, there is basically three main types of wave front. One is spherical wave front. This wave front emitted from a spherical bulb, light bulb. From light bulb we can see the light is spread along all direction spherically. Okay, then the wave front is called spherical wave front, and the amplitude of spherical wave front varies proportional to 1 by r. Okay, and intensity varies proportional to 1 by r square. Okay, intensity means energy radiated per unit area per unit time. Okay, so within 4 pi r square area, energy radiation is constant, because emitted energy will be reached within the surface of 4 pi r square. So intensity varies at 1 by r square. For cylindrical, say in case of tube light, the radiation emitted cylindrically. So here intensity varies proportional to 1 by r. In case of plane wave front emitted from laser light and halogen light also. Here intensity is constant. Okay, at any point. These are the some example of wave front. Then the characteristic of wave front is the phase difference between various particles of the wave front is 0. The wave front travels with speed of light all direction in an isotopic medium. A point source of light always gives rise to spherical wave front in an isotopic medium. In an isotopic medium, it travels with different velocity in different direction. Normal to the wave front represents the ray of light. It always travels in forward direction in medium. So now we have to know the principle of Huygens principle to explain the wave property of light, such as interference, diffraction, polarization. Okay, so Huygens told that like each point of wave front, let us say this is a source. Okay, from this source light is emitting in all possible directions, and after a particular time the wave fronts reach on that point, on that surface. Wave reaches on that surface, and he told that each point of wave front act as the secondary source of light. This is the primary source of light, and each point of wave front act as secondary source of light. That means each point also emits light in all possible directions. This is the Huygens principle. That's why in case of interference and diffraction, polarization, light may be bent. Okay. This is the Huygens principle. And now we will discuss interference of light. We know interference means two waves from two sources moving having same frequency and intensity, same or nearly same intensity, moving along same direction. If superimposed at any point, this point may be intensity of that point may be rise up or goes down. This phenomena is called interference of light. Here I have taken, let us say this is a single source is divided into two sources S1 and S2. When these two sources S1 and S2, light of two sources falling on a screen, the resultant intensity make brighter or dark. Okay, just like that the intensity form. We know the principle of superposition. If we take two waves moving along same direction having same frequency and amplitude same or nearly same amplitude, If I take to same amplitude, we know y equals to a sin omega t minus kx1 and y2 equals to a sin omega t minus kx2. If I take same amplitude and same frequency, and x1 x2 is the path, let us say this is x1 path and this is x2 path, then if we superimpose y equals to y1 plus y2, then it comes to a cos kx1 minus x2 by 2 sin omega t plus x1 plus x, sorry, minus x1 plus x2 by 2 into k. This is the resultant wave, and this is the amplitude of resultant wave. That means amplitude of resultant wave will be 2a cos k x1 minus x2 by 2. This x1 minus x2 is the x1 minus x2 can be limited delta x equals to path difference. Okay, and k we know which is equals to 2 pi by lambda, and k into x1 minus x2 is the phase difference of two waves y1 and y2, which is also we can write phi or del phi. This is the phase difference. That means the amplitude of resultant wave, if I take capital L equals to 2 small a cos del phi by 2. Okay. This is the resultant amplitude of interfering beams. So if we make a table of path difference, phase difference, then we see that if path difference is 0, that means x1 equals to x2. That means if two wave travel same path, just like that, this is the same path two wave travels, then phase difference will be also 0. That we know phase del phi equals to k into delta x. Then resultant amplitude will be a will be 2, and resultant intensity will be k into 2a whole square. K is a constant, that means 4k into a square. If I take the intensity of each wave, this wave intensity is I naught, say k a square, and this wave intensity I naught also k a square. Okay. Then here resultant intensity will be 4 I naught. Okay. If I take path difference is lambda by 2, we know del phi will be 2 pi by lambda into delta x. Then phase difference will be phi. Then resultant amplitude will be cos phi by 2. That means cos pi by 2 equals to 0. Then resultant intensity also 0. Okay. If take the phase difference 2 into lambda by 2, then path difference will be 2 pi, and resultant intensity again minus 2a, and resultant intensity also k into minus 2a whole square. Then it will be 4 I naught. Okay. If I take path difference 3 into lambda by 2, then phase difference will be 3 pi, then resultant amplitude will be again 0 and intensity again 0. That means we see the some points where path difference is 0 or 2 into lambda by 2, we get brighter region. Okay. This region is called bright fringe or constructive interference. These points are called constructive interference, and this is also constructive. This and other points are called destructive. Destructive. That means for constructive interference, path difference is even multiple of lambda by 2. That means we can write 2n into lambda by 2, where n equals to 0, plus minus 1, plus minus 2, dot, dot. And also phase difference will be even multiple of pi, that means 2n pi, and the resultant intensity will be 4 I naught. That means intensity of each wave have I naught intensity, but the intensity of constructive interference have 4 I naught intensity. Okay. In case of destructive interference, then the phase difference, path difference will be odd multiple of lambda by 2 equals to, so we can write 2n minus 1 into lambda by 2. Okay, where n equals to, here n started from plus minus 1, plus minus 2, plus minus 3, plus minus 4, and phase difference also odd multiple of pi, that means 2n minus 1 into pi. These are the conditions of formation of constructive and destructive interference. If we, here I have taken the two waves of same amplitude, that means same intensity. But if I take different intensity, what will happen? The different intensity ni, say y1 equals to a1 sine omega t minus kx1, and y2 equals to a2 sine omega t minus kx2. Then resultant amplitude, if we make resultant y equals to y1 plus y2, then we have to take some another constant, and doing algebra we can find the resultant intensity, resultant amplitude A will be equals to root over of a1 square plus a2 square plus 2a1 a2 cos del phi. Del phi means k x1 minus x2, k delta x. Okay, where del phi equals to phase difference of y1 and y2, that means k into delta x. Okay, or k into x1 minus x2. This is the relation. Where for constructive interference, cos del phi equals to plus 1. Okay, then we get maximum intensity or maximum amplitude. Then amplitude amax will be a1 plus a2 whole square, and intensity Imax will be root over I1 plus root over I2 whole square. Okay, I1 means k a1 square and I2 is the k a2 square. Okay. Then for destructive interference, then A mean then cos del phi will be -1, then A mean equals to sorry A mean equals to will be A1 minus A2, and I mean will be root over I1 minus root over I2 whole square, or we can say A1 k into A1 minus A2 whole square. Okay. These are the relations for constructive and destructive interference. If I take intensity same I1 and I2, then Imax will be 2i and I mean will be 0. If I take two large intensities difference of 2a, then for constructive interference and destructive interference, intensity will change very small. Then we cannot see perfectly the interference of light. So we have to take the same or nearly same intensity of light. Okay. So in interference in our room, if there is two light, okay, if there is two light in our room and both light emitting radiation, they also producing interference, but we can't see these interference, that one point have more intense light and another point have less intense light. That is not happening. Why? Okay, so to get sustained interference there is some conditions so that we can see the interference of light. The conditions are have here. Okay, that the amplitude of two sources have same or nearly same. Okay, same or nearly same, otherwise we cannot see. And the two sources have same frequency, must have same frequency. That means we have to take monochromatic light. Okay, and the third point, this which is most important point, that the sources must be coherent. Okay, what is coherent source? Coherent source is the phase difference between them is constant and independent on time. There may be a phase difference, initial phase difference between two sources, okay, but this is constant for any time. Okay, independent on time. If we take two light of monochromatic light, taking, let's say two, I have taken two red light, they have same frequency, also same amplitude, I can provide, but the phase difference is not constant with time. Okay, because if the lights, the two sources emitting light, initial phase always changing. Okay, so to get coherent source we need some special setup. Okay, to get coherent source, what is this setup? We can obtain coherent source by two way. Okay, one is division of wavefront, another is division of amplitude. Okay. In case of division of wavefront, that means one wave we separate or we make two source of same wavefront. Okay, which is, there is some example of division of wavefront is Fresnel by prism, Lloyd's mirror, and Young double slit experiment. Okay, here we discuss more on Young's double slit experiment also. In Young's double slit experiment, there is one single source here, and this source is split into two sources closely separated. Okay, and another way is division of amplitude. That means intensity division, we can say. Okay, the intensity of single source, we must have or we should have to take single source also, but the light ray split into two separate intensities. Okay, this is called division of amplitude. The amplitude of wave emitted by extended source of light divided into two parts by partial reflection and partial refraction. Okay. Here, if I take the one source here, this is a Michelson interferometer. Okay. One source here. This is a mirror, partially reflecting mirror. This is the partially reflecting surface. When light ray inserted on it, partially reflected and partially refracted. Okay. And then against this reflected and this partially refracted ray reflected from M2, and this partially reflected ray reflected from M1. Okay. And then reflected ray M1 and M2 form two source. These are S1 and S2. Okay. This is called division of amplitude. Here we discuss only on Young's double slit experiment. In Young double selection, we know we take one single source and we treat division of wavefront. By division of wavefront, we make two source S1 and S2. Then we get a fringe pattern, bright, dark, bright, dark, bright, dark. The center line where the path difference is 0. If two sources have same path difference here, path difference is 0. Then this is called central bright fringe, and other fringes are called first order, second order, third order bright fringe or dark fringe. Okay. The expression of fringe width in Young's double slit experiment. We know at first we have to find the path difference. Okay. Then from that we can find the where we will get bright fringe and where we will get dark fringe. Okay. Here two source S1 and S2 separated by distance d, and a screen is present at distance of capital D from two sources. And if I take a point P, then the light emitted from S1 and S2 superimpose on P and form interference pattern. So the path difference is S2P minus S1P. Okay, S2P and S1P is we get, if P is the and C is the central fringe, we know that the path difference is 0 at C. So if path difference is 0, there is a bright fringe also, because the condition of bright fringe is path difference will be 0 or even multiple of lambda by 2. Then we can find S2P equals to S2F plus PF whole square. Okay, this is the PF, and this will be X plus D. Okay, and S1P will be S1 ER square and P square, P equals to X minus D. Okay, then we can calculate by S2P minus S1P. We will be calculating, by this we can find small x. Okay, let me write D square plus X plus D whole square half minus D square minus plus X minus D whole square all to the power half. Okay. Then if we take common here D, then will be 1 plus X plus D by small d whole square. This will be D by capital D plus half of X minus D by capital D. Calculating that, we can get X capital D X small d by capital D. This is the path difference. So for bright fringe, we know path difference will be even multiple of lambda by 2. That means 2n into lambda by 2 equals to n lambda. Okay, that means n lambda equals to, for nth order bright fringe, we can write for nth bright fringe, if distance xn into small d by capital D equals to n lambda, or xn equals to n into d lambda by small d, where xn is the distance of nth order bright fringe from central bright fringe. So for first order bright fringe n equals to 1, second order bright fringe n equals to 2, third order bright fringe n equals to 3. Okay, 0 plus minus 1 plus minus 2 dot n, the value of n. For nth order dark fringe, from that we can find the fringe width of dark fringe. That means the difference of the distance from two bright fringe. Okay, xn minus x minus 1, this is d lambda by d. Okay, similarly for dark fringe, if I take xn dash, okay, xn dash for nth order bright fringe from central fringe, then uh, xn small d y capital D equals to, we can write 2n minus 1 into lambda by 2. Okay, then xn dash equals to, there will be n into d n minus half, okay, into, for first order bright fringe where n equals to plus minus 1 plus minus 2 plus minus 3 dot dot. This is the distance of nth order dark fringe from central bright fringe. For first order, half of d lambda by d. For second order dark fringe, 3 by 2 into d lambda by d. That's it. From that we can find the width of the bright fringe, that means xn dash minus xn minus 1 dash. Then also this will be also d lambda by d. That means beta 1 equals to beta 2. Okay. So here we have to remember that for distance of nth order bright fringe from central bright fringe, xn will be n into beta. Let's see, n into d lambda d by d will be beta. Okay, then n equal to n into beta will be the distance of nth order bright fringe from central bright fringe, and distance of nth order dark fringe from central bright fringe will be n minus half into beta. This is the easiest way to remember the nth order distance of nth order bright fringe from central bright fringe to distance of nth order dark fringe from central bright fringe also. Okay, and here also beta 1 equals to beta 2 will be beta. Then graphical intensity distribution of Young's double slit experiment. Here all the bright fringe and all the dark fringe have same intensities. Okay, all bright fringe have same intensity, all dark fringe, and so we can write the intensity distribution curve just like that. When phase difference is pi, intensity 0, 2 pi is the intensity maximum, 3 pi is intensity 0. That's all. Next day we will discuss more about some questions about YDAC and diffraction polarization also. Okay, have a good day.